Okay, so let's start the session now. Uh, First thing, let me present my screen. Please raise your hand one by one. Okay. Let me know your doubt. And all of you know that there is a revision session we have kept on Friday, and mock mock will be released on 22. Okay. Sachindra, yes, Sachindra Bharti.
Hello, sir. Yes, sir. Good evening, sir.
Good evening.
Sir, in graded assignment, what is the question 1 and question 5, sir? I didn't understand. Define a function fx equal to slash begin cases, something like that. I didn't get it.
Week one graded.
Not week 1, week 4,
Yeah.
graded assignment, question number 1 and question number 5.
Question number one.
Yes, sir. What does it mean? Begin cases like that, something means I didn't get this. Not familiar with this kind of questions.
Okay. So this is the meaning of that. Define a function mod x minus 3 upon x minus 3 if x is not equal to 3 and x equal minus 1 when x is equal to 3.
Sir, how you got this simplified? I mean, this is in
No, no,
representative.
no. So there is how it could showing this
I mean,
here.
somewhere you have to click or what? Earlier you also got what I am getting, but now you got something.
No, this is a LaTeX thing. If you just keep this in a LaTeX, it will show clearly. So this is this is
What is
this fun.
latex? Latex means?
Latex is writing the mathematical terms in a coding term in coding form.
Latex, Latex, latex.
Yes, yes, yes. So it is showing to all of you this the first problem. How many of you are getting this? Anyone else here? Okay, just a second. Why it is so?
No, no, we're not showing for me.
It is not showing for you. So you are term student or qualifier?
Regular, term turn.
Term student. Okay. Just a second. Let me check it once why it is showing like this. This is showing for all qualifier student. I think so. Okay, so Bharti, that ask Sachidanand, sorry. That one is asked by some Bharti. So the mostly like qualifier student, I hope that is getting, and the meaning of is that I just now showed you, right? So I don't know how it could be rectified, like how it is in some portal. This is a portal issue. In backend, it is everything is fine, but now why it is showing like this here? Let me rephrase it. Still it is showing. So here meaning of this function is please take a screenshot of it. Okay, and we will check about it. This is so meaning of that is this: define a function. The function is like this. All of you, if it is showing in the LaTeX form, am I audible?
Yeah.
Yes, sir.
So meaning of that is fx is equal to a mod x minus 3 upon x minus 3. Okay, if x not equal to 3 and minus 1 if x is equal to 3. So this is a stepwise or piecewise function. Okay, so do your at the best. Okay, I think Bharti have asked. Is that clear now? I think he left the meeting. Okay, someone else have some doubt? Anything else?
Sir, practice assignment 4, question number 4.
Yes. Which practice?
Week 4.
Question number 5.
Yes.
In this question.
Yes.
What is your doubt here?
Sir, here at x tending to 0, both left limit and right limit are equal, right?
Yes. Here the meaning is, here is this is left limit, this is right limit. And asking the first question, the first option is that both are same or both are different? Okay, and the third option is that the left limit equal to the value of the function, and fourth is about talking about the continuity. So have you tried this?
Yes, sir. What is the answer here?
So let's do this problem. So answers are not equal to and the left limit equal to the value of the function. So we can do this problem. So have you tried this problem?
Yes, sir.
How you are solving this one? While discussing this, we will discuss the concept from the last, whatever we have discussed, left limit, right limit. So how did you try this? How did you try this?
Sir, here for x equal to 0, function value is 1, and for x not equal to 0, it is given some value. So for x tending to 0 minus and 0 plus, both it should be same width.
No, so in this problem, see, uh, just one by one you need to evaluate the left limit. So what is the left limit? Left limit is, last time we have seen here. So if I will reconnect, the previous thing is here. So left limit is, suppose you have a graph of function. Okay, suppose this is a graph of a function and there is a break, jump, something is there. And this side, if you approach this one from this side to this, so left limit is going to be this. And if you approach x to again 5, so the right limit is going to be this. So this is this portion. From this, the corresponding, this one is called left limit and this one is called right limit. So my suggestion is, to get more clarification, you have not attended the last session, please, yeah, you have already attended it. So this is the left and right limit. So let's discuss this problem quickly. So here is, you have this function which is written in a stepwise. This is called stepwise in the, or the, you know, break the function kind of thing. So if you take the left limit, is going to be limit x goes to this. I think Deepa, please mute yourself. Yes, thanks. Lots of background noise is coming from your side. So this is going to be, you know, so how we have to, we know that, right? First thing, we have to see this function. This is a, you know, x to the power minus 1 function. So how it could be? It could be like this. If you see the graph of this function is like this. Okay. Now this is 2 to the power 1 by x. And we are approaching to this function, and plus 1 is there. So we can, so we have to break this function in some, you know, some, we, when break means we have to, you can like, or you can do this plus 1 later. Okay, this is just a shift. Okay, so but let's think about this one. So first we have to think about 1 by x. So 1 by x is from left side, x approach to 0, the graph is like this, because 0 is here. This portion is called left side. This means that you are, or this function, or you are approaching to 0 from left side. And how it is behaving? It is like this. It is slowly. It is no. Previously, as it is infinite, it is very close to 0. And as it will go to, or close to 0, the value is going to be negative, very faster negative. Okay. Now, just a second. Okay, so as here this one is approaching to 0, this is going, see the graph, from the graph itself it is like this. So it is approaching to very fastly this, So I think all of you have gone through, the polynomial, sorry, not exponential. So as here it is already discussed that how the exponential, this third lecture about the exponential function. Okay. So if you have this kind of, so it is approaching to 0. So now this part is, if you're from left side, if it is coming to 0, it is going to be very fast, infinite. So how it will be full, this 2 power 1 by x. What is the graph of how, when, if you think about 2 power x, and if you take the limit as x goes to minus infinite, where it will go? Or what is the graph? So anyone, what is going to be this one? What is the limit? Or in different word, if you have remembered the graph of exponential as x goes to minus infinite, 2 power x, where it will go? Anyone? Anyone have any idea? Pradeepa, Raja, anyone? Suvent? How it will go? Am I audible?
Approaching 0, sir. Yeah.
Yes. So it will approach to 0. If you have remembered the graph of 2 power x is nothing but like this. So this means that if you are going to this negative infinite, this will go to 0. That means this will approach to 0. So this, if you take here limit as x goes to 0 from negative, or you can see from the this one, it is, if you are approaching to 0 from negative, this 1 by x approaches to minus infinite, right? So here is this approach to minus infinite when x goes to 0 from negative. So finally, what is the impact on this whole? What is going to be impact here? Anyone? What is the impact here now? It is exactly the same, nothing else, right? This is exactly this one. It is a kind of change of variable. If you take x is equal to 1 by y, right? So as x goes to minus infinite, this 1 y will approach to anyone? 0, right? 0 from negative side, correct?
Yes.
0 from negative side. So if you write this term, so this is y approach to 0 from negative 2 power 1 by y approach to, this is nothing else, the same thing. It is just rewriting the variables. Just in place of x, I am just writing 1 by y, nothing else. And you are getting the same thing as this one, right? It is just a small thing. So this will go to 0. Okay. This will happen. This is the same thing. It is just written in different manner. So this will approach to 0. That means here this will approach to 0. And finally we have in the last plus 1 is there. So in the last it will be just added by 1. So this is going to be 1 finally. So that means here left limit is going to be, in the case of this, left limit is going to be 1, and this left limit equal to value of the function. So that's why this option is going to be true. Is that clear?
Yes, sir.
Can we think about for the right limit? So right limit is this portion, right? For 0 here. That means you are approaching to 0 from right side. And how this 1 by
That
x
is
is
also
approaching?
1.
No, it is not going to be 1. See that how it is approaches? Very fast infinite, positive infinite. Correct? And if it is positive infinite is approaching, what is happening in the case of 2 power x? When x is going to be very large, like approaching, this means that x approaches to infinite, 2 power x also approaches to infinite. This portion, this tells you, right? So this is the meaning here. So that means, so we can, this could be written in the same way, same behavior is here, writing to be like x is equal to 1 by y, and this means that here y, so as x approaches to plus infinite or just infinite, y approaches to 0, but it approaches to 0 positive side, correct? Because we are on this side. Okay, so if this is happening, so 2 power x could be written as exactly 2 power 1 by y, and this, as you know, approaches to infinites, so exactly the same. And this one, this portion is what? Nothing but right limit, right? Somewhere I wrote. Okay. So this is exactly the right limit. Here, this one. So right limit is limit as x goes to 0, positive 2 power 1 by x. This is exactly, this portion is exactly is this portion, right? It is written in a different form. Or this is a no. So it is exactly this one, and this means that this, and this means that this is going to be infinite. So if it is, this is infinite, so 1 by infinite is going to be what? If it is, the denominator is approaches to infinite. 1 upon infinite approaches to 1 upon infinite is what it mean that 1 upon?
0.
That means your inner, this lower part, this denominator is very large number. Infinite means what? This sign means very large positive real number, which we cannot guess. We just say that very large. Even if you say this is the large positive number, I will just add in the last, and it will be bigger than in compare of this one. And if you again say this is the very large, I will again add 9. Again add 9. So you cannot imagine in such situation, with the, if you have this kind of situation, how will notate it? If so, in that case, if such situation is happening, then we can notate it like this, infinite, this sign. Let's do that. Okay, if you are not unable to say very large positive number, let's use this sign. So this infinite is nothing but a very large positive number, but we cannot imagine that. In that case, we are using this sign. Is that clear? I hope all of you are, if you are fearing with this sign, so this sign is nothing but it's denoting very large positive number which we cannot guess. Okay, so if this is very large positive number in denominator, so that means the final whole thing is will be very close to 0. So this sign or limit or this sign, x approaches to 0, it means that this x approaches to 0, this sign means that your x is nothing but very, very small number, very, very small number. So if you say that this is going to be very small number, so I will say just add 1 0 behind of it, so ahead of it, and this is, okay. And this again you will say, so I will again add 0 and this is, okay. So in that case, how we will notate it? So to notate this kind of situation, we will use x approach to 0. So this sign is nothing but this. So sometime, not even sometime, always x approach to, even x approach to a, some any real number a, okay. That means that your number x is very close to a. And if you say, if this number, let's say your x approach to 5, it means that x is very close to 5. So if you will say this 4.999 is very close to 5, I will again add 9 here, and I will say this is very close to 5. So if somebody says this is very close to 5, I will again add 9. And this is going to be very close, very close. So whenever such situation is arises, right, these things is actually deal with this kind of sign. So if you have issue with this sign, this x approach to 5, this means that this. And this could be possible, right? This could be from either from 4 side or it could be from 6 side. So either it means that 5.00001. If we will say it is very close to 5, so I will say 0.000, right side I will add one more 0 and say this is close to 0. So this means that if x approach to 5, this means that both this one and this both correspond to this. So that's why to distinguish this, we'll use x approach to 5 from negative side. Negative side means this is smaller side, and x approach to 5 means this side from positive side. So but this both meaning are same. It means that you are very close to 5. Is that clear now? Is that clear, this problem, this sign, if you have this problem or right and left meaning?
Yes, sir.
I hope it is much clear. So sometimes signs are just, to it is just to denote something where something is not clear, like infinite. Infinite is not 1 by 0. If many times in our childhood, not even till 12th, we know that this sign means that 1 by 0, right? But it is till 12, it is fine. But if you are in a graduation, and then it is not true, okay? Because this means that it is a very large real number, positive real number, where which we cannot imagine. So this one is not telling you very large positive number. So this sign is nothing but to denote a very large positive number. And if you are keeping minus infinite is there, that means very large negative number or very small negative number. Very small number from the negative side. I hope it's made clear to all of you that how this sign is and what is the meaning of approach to. And this is this. These things are happening. So this could happen with the output also, right? See, this one you are using to close to 5. Similarly, okay. So what is the effect on outputs? So if is there any possibility that if you are keeping your number or input, or you are giving this value into the function, is there any number where this function also getting output around that? Let's say you are getting output around 6. Okay, so how you will notate this? So that's the meaning here, saying to be x approach to 5 positive or negative, fx approach to 6, as outputs are coming to very close to 6. How you will notate in that case? When you are giving input very close number, which is 5, very close to 5, then output is actually also you are getting very close to 6. How you will notate this? So to notate this sign will be, again you say fx approach to 6, and this is nothing but called the limit of the function. That this is a different word. Okay, this is called in the different word. So if it is a positive side, so we will say right limit, and if it is from negative side, then that is called left limit. Is that clear? It is, we have last time seen, with the graphical method, okay, how it is happening. But here we have seen with the more number, corresponding to numbers, real numbers. What is the meaning? So is that clear? For please, all of you, please let me know, is that clear, or what I tried to convince you, is that clear or not?
Clear, sir.
Okay, so I hope this example is also much clear. What is the meaning? So see that this option is true. So how it could be this true? It will be never true, because we know that continuity means left limit equal to right limit equal to value of the function. Then function is continuous. But here our case is left is not equal to right, and in that case function is not going to be continuous. Is that clear now? So nothing is remain to do a summary, because almost thing, even the limit at infinity is also I explained with this example. No, this example, what is the meaning here? This means that the same. So I don't know, nothing is remain to do a summary, because almost thing is with example is almost clear. I want to tell you the limit, and what is the limit if you are not understanding, and what is the case when x is infinite. We can do some one problem at when the case is x approach to infinite. So I'm just making a question fx. I'm defining a function fx is equal to 2x square, or 2x square upon 5 x cube plus 3 plus 3x square plus 2x plus 5 upon 7x square plus 9x plus 2 by x. And I'm just asking find the limit. See, I just given the tougher problem, but find the limit or find this value plus infinite fx. All of you, please try this and let me know what is the answer here. All of you, please try this.
Excuse me, sir.
Yes.
Sir, is the answer?
Okay. Yeah. What is your answer?
Sir, could you show the question?
Okay.
Yeah, sir, it is indeed 3 by 7.
Okay. All of you, please try this. Let me know if you are getting different answer. So better to writing in chat, because this class is very small, just 16 student or 18, 20. Better to writing in chat, just mute yourself and tell the answer. Or if you have any kind of query, it's better to writing, or just unmute and tell me one by one. Just raise your hand. That's the better thing, is just raise your hand. And if you are getting the answer, then just unmute yourself and tell that, okay, this is the answer. That is a good thing, no? That then I will know that, okay, all of you are at least doing something and you are responding to me also. So this class is should be in one, not only I will speak, you will also speak. Then in that case, it is going to be good. So what is the answer here? Someone else have tried this?
3 by 7, sir.
3 by 7. So how you are solving this?
So, sir, the very first thing, we'll divide each term by x cube. So, basically, the first term would tend to 0. Then, in the next term, we'll divide each term by x square. So, we'll have basically 3 by 7 after we put the limits. And the last term would, anyways, go to 0 because, in the denominator, we have infinity. So, like, simply, we have our answer as 3 by 7.
Yes. So generally, see, whenever, so you can use this as a trick. So you said right. And one thing you can use this is like a trick, that whenever there are some finding the limit as x goes to plus infinite or minus infinite. In that case, okay, in that case, just assume that x is equal to 1 by y. Okay. And if this approach to infinite, that means your y approach to 0 from positive. If this is there, then y approach to 0 from negative. So it will be very simple. Okay, this is one way to do that. If just substitute in place of x, just write the y. So here will be also changed. So here you can write x approach to infinite means y approach to 0 positive. And in place of x, just need to write 2 upon 1 by y square upon 5 by y cube plus. Like this, you can change your term, so it will be easier format. It will look like very easy. This is one way. And the second way is, right, if x goes to infinite, 1 by x goes to 0. So that means anyhow we have to change our x in the form of 1 by x. So here what we can do here, so this term, here in this term, if we divide with cube, okay, in that case, numerator and denominator both will divide by x cube. In that case, this is going to be 2 by x, and denominator is going to be 5 plus 3 by x cube. And also if this is going to be 0, so here this is not 2 by, this is just 2 by x. So if this is goes to 0, 1 by x also cube or any power n goes to 0 or any power of it for any value of n. And this is also, if you divide this term both in numerator and denominator by x square, then this is going to be 3 plus 2 by x plus 5 by x square, and this is 7 plus 9 by x. So here is 2 by x. So if it is this 1 by x goes to 0, so if any number is multiplied here, any number a, but a should be not equal to 0, and a should, yeah, that is the only case. A should not equal to 0. A is any non-zero, number, non-zero real number. So in that case, this approach to 0. So here is 2 by x is given, still it will approach to 0, and this will approach to 0. So finally, first term will approach to, because numerator approach to 0, so that's why the whole term will approach to 0. Similarly, this one, this approach to 0, this approach to 0, this approach to 0. So finally, 3 by 7 will only remain. And here is again 2 by x is here as the case, and this will go to 0. So finally, 0 plus 3 by 7 plus, so this is going to be what? 0 plus 3 by 7 plus 0, and this is 3 by 7. So by 2 ways, 2, 3 way, anyway, so by say first way or by second way you can do yourself. But this whole both way or any kind of method, it is just thinking about how your number is behaving and what is going to be the finally output. So here is thinking is that you are doing something in input case and what is happening in the output case. And if it is the function is more tougher, you have to break your problem in the steps, or you have to break your function in some parts. Like here, even I don't know that how it could be solved, but one by one. So first attack here. So to attack here, you just attack this portion, 1 by x case, and then attack 2 power 1 by x, and then attack the whole denominator, and then attack whole this numerator and denominator. So you have to attack 1 by 1 if you don't know your function. Okay. So this is about the limit of function at infinity, and one-sided limit is we have already talked. One-sided infinite means left or right limit, and I think nothing is remain here. See, again, this one is given the sequential approach, okay, but it's depend on you, right? That how so best is that either you can. So we have already last time discussed the sequential meaning and how the limit means in the case of sequential. So here is the same case, just sign thing, negative or positive. You will get a sequence lesser than that number. So here is lesser than that number approaching to exactly that number. And here is you will get a sequence or not get a sequence for every sequence which is of this case, means every sequence which is greater than 0 for all n. In that case, sorry, all n, and n is goes to 0. Sorry, x naught. In that case, function is approaches to L. So same, exactly the same limit, same definition, only the left and right meaning have changed. If you want, you can go with this one. I have already discussed, or we have just now discussed in more deeper format here. I hope this is much understandable to all of you what it means. Okay. This is also true. So however you want, you can proceed. And power exponential is better. We just now discuss with an example here how it is, how you will do this. And this problem is more tougher. So here is, in this case, in these cases, you have to break your problem in stepwise, or you have to think your problem in stepwise. First step is smaller or easier portion, then extend one by one, and extend to whole function. Slowly, whatever you know. Okay. Computing the limit is nothing. Riemann continuity we have already discussed. Exponential functions. Nothing is Riemann to do a summary. So I don't know. It's better to all of you please let me know your doubt. That would be good. No one have. So let's do one thing. I am just going to discuss a practice problem, okay, in a very short manner. One by one we'll take a practice and we'll discuss. So it will discuss. Then it will be. I hope it will be much clear. So I'm just taking the first one first.
Yes, sir, it will be better, sir.
So here, find the value. Here is limit is given, and we want to find the limit when x is approaches to 2. So here is the problem. Here in this problem, if you directly substitute this to here, you will get 4 plus 8 minus 12, which is 0, and it is exactly same answer here. So numerator and denominator both, once you substitute 2, it is 0. So in these cases, directly we cannot put and find the limit. So how we can do? So this is a process, If process is that if you just take 2 and substitute numerator and denominator, and if there is no issue or if you are not getting 1 by 0 or upon 0 form, okay, something, if such case is not arising, or 0 by 0 form, infinite by infinite form, 0 by infinite form, if these cases are not arising, means you are getting numerator and denominator both as a real number except 0. In that case, you will just substitute and say that this is the limit. But here this is not the case. So how we can do? We have to do some manipulation, some cancellation here, something we have to think. So in that case, you have to do here the factorization of this quadratic function. All of you, I hope,
Yes,
that are the quadratic week 1 is there, and if you do the factorization here, this is 12 and this is 4. So this could be written as, means here the way to factorize is that you have to think 12 as something 6 times
2,
and this is minus here. That means from 6 respect to this will give 4 with respect to x. That means x and minus 2x minus 12. That
12.
means you can write this 4 in this way. And now you can take x as common. This is x plus 6. And minus 2 you can take common. This is x plus 6. So we are done with, numerator. So this is x minus 2 and x plus 6. Let's think about again the denominator. So I'd again attack this last term, and this could be written as 7 into 2. Here is minus sign is there. That means 7 minus 2 will get 5. That means x square plus 7x minus 2x minus 14. We can write like this. And here is we can take common as x and x plus 7. And here from this we can take 2 common, x plus 7. Now from these two terms we can take common x plus 7. So finally x plus 7 and there is minus 2 is there, x minus 2. So see what is happening here. Once you did factorization, you got the term where the create problem with where you get term factor where it is actually creating a problem with 2. So we can now cancel it out. And now let's do again substitution. And again, if we'll do substitution, then in that case, if you substitute here 2, you will get here 27 into 8. And here is 8 into 9. So now you are not getting denominator and numerator both as a 0. You are getting a real number. So this is going to be your limit. This is the way to find. And this is the only way, or not only way, this is the way to find the limit. Okay, let's do next problem. In this problem, you have a function and plot it. And somebody is given, this is a, Edwin is there and he plotted in, Desmos, and the function is given this expression and said that so here is the information that function is continuous at every point. We just use this one because now whatever he said, he forgot something and value is missing, and in place of he used mn and value, the missing value. So something he kept, and this is an context is given here, and but we have from this contextual problem we have to extract the main or mathematical term which we will use to find the value. So here is extracting the sentences continuous at every point. So that means our function is actually continuous. So let's do now. This is only anything. So here is, see that this portion tells you that problem at only 0 and nothing. So if it is less than 0, it continues everywhere. At 0, this value is given. And right side, in greater than 0, function is given linearly. Left side given exponentially. So everywhere is fine. The problem is at only 0. So that means we have to attack on 0 and have to find left and right limit at 0 and function value at 0, and use that continuity condition that left limit, right limit, and function value should all equal to 0, and then it will become a continuity. You will get some nice equation in the form of m and n, and you just solve these two. Already you have been solved in week 2, two variable case, and that's all. So let's find the left limit at 0. So limit x approaches to 0 from left fx. So that means if it is less than approaching to 0 from left, means left side of 0 is this portion, right? This is 0 and left side means here is negative, means lesser than 0 values. And lesser than 0 values case, your function is defined like this. That means limit x approach to 0 negative and 2 power x plus 3. So in that case, you have this exponential and you have, remember, the exponential 2 power x is just, nothing else. So around 0 is also approaching to this 1. 2 power x approaches to 1. So finally, n plus 3 you will get as a limit. Let's find the right limit. 0 positive fx. In the positive case, this portion, the function is behaving like this. That means limit x approaches to 0 positive, your function is defined in the positive case like this. And this limit is nothing but 1. So you have both these two. So let's do, so it is already given function is continuous. That means this left limit, right limit, right limit, and function value at 0 all should equal, then it will be continuous. So let's make an equation. Left limit is n plus 3 and right limit is 1. So that means your value of n is going to be minus 2. And right limit is equal to function value. Function value is given at 0 is, this is what, m minus 2. So m minus 2 should equal to function, sorry, right limit. Right limit is given 1, you have this one. So that means m minus 2 is 1, that means m is equal to 3. So you got these two values. So which option is going to be 3, you can check now. Okay. Is that clear?
Sir, can you repeat the last step?
Where, this one?
Yes, sir.
So your left limit is, we have calculated n plus 3. Right limit is calculated 1. So what is the condition you have? Left limit, right limit, and function value all should equal. So left limit is what? N plus 3. And right limit is 1. So we have this one equation, you got n is equal to minus 2. Let's take these two equations. Right limit is already 1 and function value is at 0 is m minus 2. You have already one equation. This means that your m is going to be 3. So you got these two values. Is that clear now?
Yes, sir. Clear.
Let's do next problem quickly. Maybe half of the I will do, I think. Okay, let's see that. So you have this greatest integer function. The first thing you have to know what is the greatest integer function, and you have to find this limit. What is the greatest integer function? So again I will write here, solid and dot point and circle, or solid point and circle. So what is the way to write that? Greatest integer function is, that means if you have 2.5, okay, and if you have some 2.5, then greatest integer value is going to be exactly
2.
And what is the case of 2.5 minus 2 point? What is the value here?
It will be also 2.
Minus 3.
Greatest
Minus 3.
integer less than or equal to, right? So greatest integer, which is less than this. So greatest integer less than this is going to be what? -3, right? Which is greatest integer but less than. So -3 is less than this number. Okay. So word is hidden greatest, but in the negative case, it is actually always -3, or even some one added is there. Okay. So this is the meaning of greatest integer. So what is the case when x approach to 9 positive? If you have this function, what it means? So I hope just now I have cleared right. What is the meaning of this one? So suppose you are keeping here that number. X is what? Very close to number 9, and here is plus sign means from positive 9. So what is going to be, tell me, what is going to be this in this case?
9.
All of you now
9.
done better, a very clear manner. So what is the meaning? Someone else? Someone? Anyone else? What is going to be 9 or 8 or
9.
11, 10?
9.
9.
9. So this is going to be just now said, right? This means
9
that
plus
your number is actually very close to 0.001, and you will say this is close to 9. And again, I will add 1 more and say it is close to the 9. So that's the meaning here. Always, if you take greatest integer less than, in any case, it is going to be 9. And this is what in this case. Now we can directly say what is going to be in this case. This is the for the lesser case to negative. This, I hope it is now clear. So anyone, what is going to be the meaning or what is going to be the value finally?
-3.
No, here is not minus at top. Sorry, not ahead. It is at top here. What it meaning that if it is in the top, it is, if it is at the top.
1.
Yes, left limit here is asking. Means your number is actually close to 2, but from the left, which is from 1.999 case, right? So in that case, greatest integer less than, in that case, it is going to be. So this is 9 and this is 3. This is going to be finally 6. 3 times 1. So this is going to be 6. Okay. I hope it is much clear. Let's move to the next
Sir, it
question.
is
Is
there,
there?
in the question they given that 5 into limit, like that, na?
Sorry.
Value of 5 into 5, the question asked there, na?
Oh, so here is 5 into, okay. So if it is 9 into 5, then finally. So 9 into 5, it is going to be 45. And then 3, it is going to be 42. So you can check the answer here. 5 times 9 is there. Okay, so I just missed that. So let's move to this problem. And I'm not going to discuss this problem because we have already discussed this in the last session. Okay, and very clearly, very easy manner. I am just skipping this problem because it is just a repetitive thing. And why I am just skipping also, because we have in the last session we have discussed with in the form of pictorial format. We have discussed this form. Many forms we have discussed. This one, and also these all. This one also. 4 problem we did very similar to this, and also we have already discussed that this problem also in a very small time. I'm just skipping this problem. Okay. Let's move to 5th problem. We have in starting we have discussed in a very, have spent much time here. Let's do the 6th problem. So we have given a function which is in the mod form. So see, something it is a kind of created problem, but let's discuss this one. Okay, and in this problem we have said is right continuous. So right continuity is nothing but just a right limit is equal to function value. So let me again, it is right continuous is nothing but the definition. So I just not tell you, I didn't tell you about right and left continuity. The reason is nothing but the, if you just watch the lecture, it will be clear. It is just in one word. If left limit is equal to function value, then it is called left continuity. And if right limit equal to the function value only, okay, this is not true in that case. So in that case, this is going to be right continuous. So left limit should not equal to the function value, but right limit is going to be function value. In that case, this is called right continuity. So if a function is continuous, means left and right both are left limit, left continuity is there and right continuity also there. If a function is continuous. Okay. In this problem, let's find first right continuity is saying, so let's find the right limit. So right limit is going to be when the case is at 4. So that means it is asking x goes to 4 positive fx. Okay. In this case, this is the value we want to find, and it says right continuity means this should happen. The information is given this. Means equation is already given. Okay. We have to find this value, this portion. And this is already given k. And asking find the value of k, that means we want to find the right limit. That's all. So let's find the right limit. Here it is given the mod function. So how we will tackle this? Here is mod function is given. So here is your x is, so again, what we can do? We can break our function. So here is says x approach to 4 positive. Correct? That means, is this number x is greater than 4 or less than 4? Anyone?
Greater than 4.
Greater than 4. So in that case, if you are just subtract here from 4 positive to 4, what it will give? It will be a positive number or negative number, finally whole?
Positive number.
And positive, when you are taking mod of it, it is going to be positive. The same. And in here is in denominator with the same number. Positive divided by positive. It is going to be
1.
1. Correct? So finally, the limit x approaches to 4 positive, mod x minus 4 upon x minus 4 is nothing but 1. Correct? By this way only we can think. So that's why today whatever we have discussed this portion, no, this is very, very important to understand this one, this all. This is just understanding the notations. If you understand the notation, nothing is remain now. So here this portion we have very clearly and very slowly we have discussed. So that one is very, very important. Okay. So now if you have some tougher problem, just break your problem in steps. Okay. So here is this problem. We will just first think about numerator and then denominator and added both and finally got 1. Okay, now still some multiplication part is remain here. So here is no problem. It is just substituting the value 4. So that is going to be 4 plus 1 into this portion is 1. And it is going to be 4. So finally the whole, this
It's
right
5.
limit is going to be,
5,
sorry,
sir.
so it is going to be 5. Yeah. So finally this whole is going to be, right limit is 5. And this value is, right limit is equal to the function value as right continuity is given. So finally k is equal to 5. Clear? Better? Clear now?
Yes,
I
sir.
hope mod value or mod function will
Yes, sir.
now not disturb you much.
Yeah, it
We
understood.
have discussed even the greatest integer will also will not, disturb. And I hope, see, here we are all problem did here, whatever the problem we did, all 4 problem we have discussed, and from 4, 3 of them are actually stepwise breaked function, and one by one we have discussed. So I hope it will much helpful for you to understand how we will tackle this type of function. Okay, let's do the next problem. So here is something is given. I am not going to discuss the options because here is asking k is -5, then function exists at 4, not exist at 4, left continuity, right continuity. Now I'm just leaving the part for left continuity. I hope it is much clear, and you can check it is going to be -5 or 5 or anything else. We can skip this part. Because let's leave this problem you to solve yourself. Because right part we did, right continuity we did, left part or existence of function is just leaving. Okay, and here is the 8, 9, 10 problem is given. Let's do one problem. Even we can understand this problem, this only the context, then nothing will be remain there, because it is asking gain function is continuous and at which voltage amplifier is gain is undefined, and so you just need to understand this context. So here is an electrical engineer is designing a signal processing circuit that amplifies weak audio signals. Okay. Circuits input voltage is denoted as V, is passes through an amplifier where the gain function. So finally here is, so some instrument is installed. When you pass through, input voltage means here is input has, that's why I was saying function is nothing of a kind of machine. Here is that machine is written in the form of function. What is that function? Something is in that circuit, something more. I don't know what is that exactly circuit, but something is did in that circuit, and anyhow it amplifies, the weak audio to strong audio, and how that weak audio changed in the form of voltage, and something that, some amplifier added, and something that changed to amplified form, how you will get output. So this is given your function. This portion tells you if you put here or give input in place of V, you will get output this value. Now options are given. Is this gain function is continuous? So is that continuous? Every continuity is asking for continuous at every point. So this function, where is the problem in this function? Where is the issue in this problem? Where is the issue? Where is the problem where it function may not be continuous? Anyone can tell me where it may not be continuous? Just looking. While looking, Can you tell me that where it may not be continuous, where we have to check? Where is needed? We have to check. At which point? What is the v value or x value if it is the function is given in x form? What is the x value? We have to at which value of x or which value of v, at which value of v, we have to check is that function is continuous or not. Anyone? No one? Where is the issue? If all of you are getting, anyone can unmute and tell. If no one is getting, then I will tell you. If anyone is getting, please tell. Then it will be, one responding with me and you, and the class will be, I don't know. I am teaching with a boring way. I don't know.
Sir.
No, sir. No.
0 voltage.
No, that's the, if you then anyone can, anyone else? So why you are saying at 0 there is a issue?
0 plus 2, 2 power the power of 4. So we are getting root to the power of 0. So
Yes. Yeah, I just missed that. Yes. So only the problem at 0. If you accept 0, if you keep any value of, then the denominator will always be a real number, and it is fine. So problem only at 0. So we have to check is that function is continuous as 0 or not. Then the 8th problem will be done. Okay, so we have to find that function value first at 0. So function value is not given here. So you have to find the left limit and right limit, and the function value is not given. So here that means even, see, at 0 the problem is there. So directly, you can tell that, I don't know, this function is not continuous. Then in that case, as the function value at 0 is not given, directly you can tell. Because function value should be given. Without even solving this problem, you can neglect the option. Because once you started solving this problem, the left limit, right limit, and function value should equal. But here, what is the function value at 0 now? It is not given itself. So directly you can say it is not going to be continuous. Now next problem, at which the following voltage V values, the amplifier gain is undefined. So again the same, it is undefined at 0 only. The same, it is nothing but checking this is directly the 8th problem itself giving the 9th. So yeah, so at -2 is also have issue. If we keep here -2, it will be 0. Yes. So it will be a root over. So only we will check for the continuity is which part. We'll check the continuity in right side. The output is going to be positive. But so how we will solve this problem? We will just keep one by one options. 0, yes, there is a issue. -2, yes, negative output. In the root over you will get, so root over negative value you'll get, and then in that case again you have an undefined case, and 2 you will substitute, then it is fine, and 4 you will substitute, it is fine. So one by one you can do. 9th problem also. The 10th problem, see this problem even we don't need even to do some calculation. It is just with the thinking a small thing. So what is the limit of the amplifier's gain as input voltage V approaches infinite. At infinity. So we need to find just limit at infinity. So infinity is, all of you just now discussed. We have at finding the limit. So this last 10th problem is asking for limit at infinite. So here this could be the last 10th problem could be think as a limit v goes to positive infinite voltages. Talking about 30 minus 14 5v plus 40v plus 20 upon root over v plus 2 whole square minus 16. So here what we can do, what we needed, how we can get this value, what we can use to divide numerator and denominator here. What we will use? VQ, V square, V itself, or nothing. Just substitute. If we'll substitute, then we will get an infinite by infinite case. So here is 4 is given, I think. 4, I just wrote 2. So here root over this polynomial is given, and this means that, this degree of this term is going to be 2. That means if you divide with, v square, numerator and denominator both, that's sufficient. So here is directly you cannot do numerator and denominator if you just divide this. So this is going to be 5 by 5 plus 9, 40v, 40 by v plus 20 by v square upon. If you divide denominator also, then in that case, this will go v square inside and it will become v. Sorry, it will become, it will become v power 4. If you do divide with v square, in root over will go, it will become 4. So now this will become v plus or 1 plus 2 by v or 4 minus 16 by v power 4. Now as x goes to or v goes to infinite, this goes to 0, this goes to 0, this goes to 0, this goes to 0. So finally 5 by 1 you will get. So finally answer is 5. Is that clear? So we have discussed almost practice of week 4. Okay, that's all for today's session. Anyone have doubt, please let me know, conceptual or anything. Or now I am thinking to close the session. So anyone have doubt, please let me know. Okay, thanks. Thanks everyone for joining.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, it will be a better pattern there.
Sorry.
So currently, there's also a thing discussed with Srikanth sir also there. So initially we go through the theory part, the lecture wise and video wise, all that, and solving the some questions
Activities,
from the
problem or
activity
practice.
questions and the practice assignment. So most
Yes.
of the different types of questions will get solved combinedly yourself and ourselves there. Right, just current is right now we have solved na.
Yes.
Practice assignment there. So all the questions or all the topics or all the topics get covered in that all questions there.
Yes.
And we get the idea. So it will be the good way to further the
Yeah, to
idea.
discuss or keeping this live. So yeah, thanks, Sam.
Yeah. So I also suggested the same thing to the Srikanth sir also there. So initially, from the beginning of the week, we'll go through the theory part, lecture wise, and some few questions from the assignments and this activity questions. and we'll discuss the practice assignment, because most of the questions are different. 10 questions are there, so
Yes.
it's possible we can solve in 1.5 hours there. So
Yes.
and all the topics get covered, and theory part also, that with that particular questions there, and we'll get the idea, and it will help us to solve the questions from the graded assignment there. It will be better.
Yes.
And most of the other for the other electronics and the C or the BDS, we're also following the same pattern there.
Yeah, they are first discussing the concept and then
Yes,
solving.
and solving the activity, not activity. Mostly other don't have the activity questions. In maths, having most activity questions.
Yes.
Practice assignment mostly solving in live sessions. So both interactions and the getting clarity about the questions, understanding and all that. So it is helping us to solve the assignments and the getting the concept clear betterly.
Yes.
So
One
this
thing I
pattern
am just missing here from the class is that all of you are not responding me. So I am thinking that it is I'm teaching boring, or
not boring.
how all the best thing is that like all of you are not understanding. So this is the one part I am just thinking that okay, I don't know.
Sometimes they are not understanding. That's why that is not
Please
much
stop me. So whenever, see, if I am going fast or slow, or if you're at any point, any kind of, if it is a silly kind of thing, just
Yeah.
let me know. I will discuss that. Even a small notation, if you let me know epsilon, why this sign is epsilon is kind of,
Yes.
what is the meaning? Please let me know. I am here to discuss that, and that would be good to know that at least you want to know. So if you are thinking that is silly, but maybe I will think that is important,
Yes.
so that all of you get that. Okay, if you are missing that, so please, any kind of doubt. So at least now week 4 is there. Now the qualifier will happen on Sunday.
Yes.
They had weeks, so make the classes will be, if it is one corresponding, like talk, conversation will be more in the session,
Yeah.
then it would be good.
It will be
And
better
also
for
I will
us.
not I will not feel also boring, and all of you will also not feel boring. And if you are getting any kind of any kind of silly, any kind of doubt, not understanding the concept, see somebody is like Pradeepa said, sir, I'm not understanding the, I just tell her with the different manner, so that I will try to convince you, I will tell you again in the different manner, so that you can understand. So I am here to to solve at least any kind of mathematical related query, doubt, we'll discuss here. So
Yeah.
please
I
ask.
request it is a better pattern to solve the practice. I mean, at least in the live session. Anyhow,
Yes.
we're getting the solution for later on PA and GA.
Yes.
Directly written solution PDF format, but it's not getting that clarity how it is that how it is used, why that this is the solution there. So many questions are there. So if you solve in this pattern, in this manner, so it will work better for us there, because for the C programming, the electronics or the BDS and all that, we're following the same pattern there. This going to the theory part initially at the beginning of the week, one session. In second session, we're solving the practice assignments, and it help us in better way
Yes.
to get the concept of the basic concepts, and the to solve the graded assignments problems and all that.
Yeah.
Because most of the what happens there, student ask random questions, question number 2, question number 3, question number 5 for the graded or the practice assignments. But if you solve one by one, then so it will be a good thing, and later on anyone can go through the videos and you can get the complete part on the recorded session there.
One thing I will request, that once we have, you have suppose some doubt we have discussed, some not doubt, some concept we have discussed. So it will be good if you ask some doubt from your side, like either it could be from activity practice or from some other book.
Right.
That would be good. That okay, so that I will make it note that okay, while discussing this concept, or while discussing, or once we discuss that concept, let's do this problem. So somebody has asked this, so even myself I will choose. It is better to, you will tell me that okay, this problem would be good, or you are not understanding, or I don't know which concept in this problem. I thought maybe this concept will be used. So it will be, so no, this is, it will be like a conversation session, like more conversation.
Yes.
Actually, my concern is that I have feel that today, even from 2 days on Sunday session, very less conversation is here. Only I am telling, and all of you are listening. So this is not good. So because I'm not a professor, I'm just instructor, and so you don't feel even no fear. Freely you can ask.
Yes. I think all of us agree with you, and from the next session, all of us will be participate in good conversation and discussion.
Yes. Thanks, Sam. Thanks, everyone. Good
Thank you,
night
sir.
to all of you.
Thanks.
Good
sir.
night.
Thanks.